car is towing a trailer along a straight, and it starts off being a horizontal road, so picture like so, nice long tow bar in case I've got thrust or tension in there. That's the car, it's 900G. I always start with the weights to start off with. It's 250G, and then do the normal contact force of the trailer, normal contact force of the car, 600 newtons resistance to motion for the car, and 150 newtons resistance for there. There is a driving force, I'm going to call it D, and start off with the pulling force exerted on the trailer is 0, so there's nothing going on there. There may be tension or thrust later on, but there's nothing there at the moment. If we do have an acceleration, so I put down the acceleration, and I'm going to have to show that the acceleration is 0. So for that, it is 0 here. Acceleration is minus 0.6. The acceleration of this bit is the same as the acceleration of this, same as the acceleration of the whole thing, but I know all the forces. So if I'm just thinking about this, then I will get, so for the trailer, then I'm going to get resultant force equals mass times acceleration, and the resultant force is nothing going forward, so it's minus 150, because I'm resolving in that direction from left to right, equals the mass 250 times acceleration, so A equals minus 0.6. That's the first part. And now for part B, the driving force exerted by the car. Well, that one I could consider the whole object, but I'm actually just going to consider this bit because there is no tension or thrust going behindwards. So now for the car, exactly the same. We're going to resolve and go in the direction of the acceleration. Resultant force equals mass times acceleration, and that is D minus 600 equals the mass 900 times by the acceleration is negative 0.6, just works it out, and that gives me that D equals 600 minus 0.6 times 900, which is 60 newtons. And then for C, I've got to calculate the distance required to reduce the speed of the car. So this is just going to be a Stuva type of question, equations of constant acceleration. That's minus 0.6, just works it out. It goes from 215 from 18. I want to work out a distance. I want the formula with no t, and therefore that'll be v squared equals u squared plus 2as. So 15 squared equals 18 squared minus 2a is 1.2 s, and so therefore we're going to get s equals 99 over 1.2, which equals 82.5 meters. And now we're going to go on to part 2 at another stage car. They're moving down a slope inclined at 3 degrees. So that's my slope, that's 3 degrees. I'd never draw it too shallow because it's hard to see what's going on then. So an object going down here, car and things. As always, first off put the weights in there. That's 250G, that is 900G. Normal contact force, that's RC, that's R for the trailer. There is a driving force, and it actually says the driving force is 980, so that is 980. It says everything else that's unchanged, so that's 600 newtons going backward there, and that's 150 newtons going backwards there. We do have an acceleration, it goes down like so. I think we're pretty much there. So we've got to find the acceleration of the car and the trailer. It's quite nice to dot this back here so you can see it. That's 3 degrees, and this bit here, that's also 3 degrees there. And then for the part A, so the resultant force is mass times acceleration down here. And what's got there? We've got 980 going down, we've got 600 going up the slope, we've also got another 150 going up. We've also got this bit down here, So it's going to be plus 900g, and that'll be sine 3. And we got this bit here, which is 250g sine 3, and that equals the whole, the mass, which is 900 plus that, which is 1150 times by A. Work this out. A is 819.826 over 1150, which equals 0.71289 meters per second squared. For part B, we now need to work out the pulling force exerted on the trailer. Where it's accelerating, there's going to be a tension here, equal and opposite, and now we only have to consider this part of the object here, put together with the acceleration. So we're looking just at the trailer. We got resultant force equals mass times acceleration. What goes down? We got T plus 250g sine 3 minus that 150, and that equals the mass, which is 250 times the acceleration. I just worked out 0.71289, and so T equals 178.223 plus 250 plus 150 actually, and minus 250g sine 3, and so T equals 200 newtons, and that's my answer. Key is the diagrams, and that's question 5 done.